Here's another application where we can use our power series expansion. We have a power series expansion for cosine of x, and by substitution we can now figure out a power series expansion for cosine x to the 5. So if cosine x is the sum from 0 to infinity of minus 1 to the n, x to the 2n over 2n factorial, then we see that if we substitute x to the 5 for x, we get cosine x to the 5 is 1 minus x to the 10 over 2 factorial plus x to the 20 over 4 factorial, etc., plus minus 1 to the n, x to the 10n over 2n factorial. And now suppose I want to find the limit as x goes to 0 of cosine x to the 5 minus 1 over x to the 10. When I subtract 1 from the power series expansion for cosine x to the 5, I get a bunch of terms, all of which have x in them. So I get minus x to the 10 over 2 factorial plus x to the 20 over 4 factorial, etc. And now if I divide by x to the 10, I get a constant term, minus 1/2, plus a bunch of terms with powers of x where the power is greater than 1. In fact, it's greater than 10. So if I'm looking for the limit as x goes to 0 of cosine x to the 5 minus 1 over x to the 10, then that's the limit of the left-hand side of this equation, but it must also equal the limit of the right-hand side of the equation. So it must equal the limit as x goes to 0 of the power series minus 1/2 plus x to the 10 over 4 factorial minus x to the 20 over 6 factorial, etc. And now power series are continuous functions. So I have the limit as x goes to 0 of this power series is the value of the power series at x equals 0. So if I plug in x equals 0 into the power series expression, I get minus 1/2 because all of the terms with a positive power of x disappear. Therefore, the limit on the left equals the limit on the right, which equals minus 1/2. And I've solved this problem using the power series expansion of the quotient, the cosine of x to the 5 minus 1 over x to the 10. Now here's a list of well-known power series, and this is a bunch of power series that you should keep in mind, most especially the expansion of 1 over 1 minus x, the expansion of e to the x, the expansion of sine x, cosine x, and perhaps tan inverse of x and 1 plus x to the n.